Okay, here's a logarithm function that has been shifted by subtracting 1 inside the function and by adding 4 after the function. So we need to know first, what does the basic logarithm function look like? And then how do these change the graph? Right, the basic logarithm function has an asymptote at x equals 0 right on the y-axis, and it has an x-intercept of 1. Right? This minus 1 in the function should shift the entire graph 1 to the right. That will include the asymptote. So here's my new vertical asymptote. Right, it is x equals 1. All right, now this plus 4 means we're going to shift the whole graph up 4. So where we used to have an x-intercept here, it's gone 1 to the right and up 4. Right, I've gone from this point, 1 right, up 4. Right, this is where our x-intercept has moved. Now it's not even an x-intercept. The graph still has the same basic shape. You know, it approaches the asymptote like that. Okay, the x-intercept is here. Let's do that one first. Okay, how do you find an x-intercept? You substitute y equals 0 and solve for x. 0 equals log base 5 of x minus 1 plus 4. Log base 5 of x minus 1 equals negative 4. All right, convert to an exponential. 5 to the negative 4 equals x minus 1. So x equals 1 plus 5 to the negative 4, which is 1 plus 1 over 5 to the 4th, which is 1 and 1/625th, which you could convert into a decimal if you want, but that's essentially just a little bit more than 1. Okay, the domain, right? The domain are the x values. The logarithm function generally has a domain of x greater than 0, but since we shifted it 1 to the right, our new domain is x is greater than 1. Right? The logarithm has a range of all real numbers, and shifting it 1 to the right and moving it up 4 still, it does not change the range. So we have all reals.